Section 6.5 is all about applications of decimals and percents. And so we have 6 objectives to meet. Number 1 is to perform operations of arithmetic with decimal numbers. Then we learn about rounding whole numbers and decimals to a given place value, and then performing computations using percent, and then convert among forms of fractions, decimals, and percent, in other words, to show the equivalence that fractions, decimals, and percents are the same. And then find percent increase and percent decrease, and apply formulas involving fractions and decimals. So there are different applications we'll be looking at. First of all, when we talk about adding and subtracting of decimals, if you do it manually, you line up the decimal points in the column and then perform the operations. I'm not going to do an example of this because very few people ever add and subtract decimals manually. In most cases, they use calculators, and in this case, the decimals take care of it themselves. If you input the numbers properly, you don't have to worry about whether a decimal point winds up. A similar comment applies to multiplication and division of decimals. Again, most people, probably 99.999% of people who multiply numbers, especially numbers with decimals, use a calculator, and then the decimal places appear correctly automatically. And the same is true for division of decimals. The decimal point will wind up at the right place. So that's why I don't cover that in a whole lot of detail. Now, here are some things about rounding of numbers that can always be a bit of a challenge, and we'll be doing some examples of that in just a moment. But rules for rounding whole numbers: locate the place to which the whole number is being rounded. Number 2, step 2, look at the next digit to the right of the place to which the number is being rounded. Then if the digit to the right is less than 5, replace it and all digits following it with zeros. Do not change the digit in the place to which the number is being rounded. Okay? And then for the case where the digit to the right is 5 or greater, replace it and all digits following it with zeros. But also add 1 to the digit in the place to which the number is being rounded. In other words, if adding 1 to 9 replaces the 9 with 0, and then add 1 to the next digit to the left. If that next digit is also 9, repeat this procedure and so on, always going to the left. And I'm sure you've done this before, but this is the exact definition or specification, how the steps how to do this. And then rounding rules for decimals. Steps 1 and 2 are the same as for whole numbers. Step 3a is a digit to the right is less than 5, drop all digits to the right of the place to which the number is being rounded. Do not change the digit in place to which it is being rounded. And then the other case is if the digit to the right is 5 or greater, drop it and all digits following it, but also add 1 to the digit in the place to which the number is being rounded. Again, when adding 1 to a 9, use the same procedure as for whole numbers. And we'll be looking at some examples in just a moment. So in the next example, we look at rounding, and the number that we're looking at is 54,793. So we are rounding it to the nearest 10,000. So there's ones, tens, hundreds, 10,000, and 10,000. So to the nearest, 10,000, which would be 50,000, 60,000, and so on. Now the number following the 5 is a 4, so we make all the following digits equal to 0, and we leave the 5 as it is. So in other words, for the A part, that becomes 50,000. If this had been like a 5 or a 6, then we would have made it 60,000. But since the digit following the 5 is less than 5, we make it 50,000. The B part, we are supposed to now round it to the nearest thousand, so we look at the number 4, and that's followed by a 7. So in other words, we round the number 4 up to 5, so this then becomes 55, followed all by zeros, 55,000. And for C, for hundreds, well, the hundreds are here, 793, so it's followed by 9, so that becomes then an 8, would be 54,800. And for tens, well, here the tens, and so the 9 is followed by 3, so we don't change the 9, but we put a 0 instead of the 3. So this becomes 54,790. Similarly, when we look at the next exercise, 453,258, 100,000, well, we have 400,000. The 4 is followed by 5, so therefore we round that up to a 5, and so for the A part, the 4 becomes a 5, it would be 500,000. And then the B part is rounded to the nearest thousands, so it's 453. And since the 3 is followed by 2, we don't round up the 3, so this becomes 453,000. And then for the hundreds, here the 258, the 2 is followed by 5, so we round it up to make that a 3, so it becomes 453, and then 300. In the nearest tens, the 5 is followed by an 8, so the 5 becomes a 6, followed by 0. So that would be D is equal to 453,260. The next number is 0.892451, and the A part is to the nearest hundred thousands. So here's tens, 100s, 1,000, 110,000, 100,000. That's followed by a 1, so we just drop the 1. So this then becomes 0.899245. To the nearest 10,000, so we look at this number now, and here's the nearest 10,000. It's followed by a 5, so the 4 is increased by 1. So this becomes then 0.8925. And when we talk about nearest thousands, so near 1,000 would be this digit here, and since it's followed by 5, it's increased by 1 to 0.893. And to nearest hundreds, since the 9 is followed by 3, we just leave it, make it 0.89. The nearest tenths, since the 8 is the tenth place and it's followed by 9, it's increased by 1 and becomes a 0.9. And then 1 or 1 unit, since 0 is followed by 9, this becomes a 1. Next, we'll be covering the concept of percent, and I'm sure you're familiar with that, and it's a review basically, I think, for most of you. And the word percent means per 100 or per 100, and that's what the symbol represents. It represents percent. So 1% means 1 divided by 100 in fractional form, and this would be in decimal form, and that's in percentage form. And again, I'm sure you've seen all this before. Now, converting between decimal to percent. To convert a percent to decimal, drop the percent symbol and move the decimal point 2 places to the left. Okay, that's from percent to decimal. Inserting zeros as placeholders if necessary. And we look at some examples of that. On the other hand, if you convert a decimal to a percent, move the decimal point 2 places to the right, inserting zeros as placeholders as needed, and attach your percent symbol. So doing it will probably explain it better than reading it over and over again. So let's do some examples. Before we do that, let's read about how to convert a fraction to percent. So you convert a fraction to percent, convert the fractions to a decimal, and then apply the rule for decimal to percent. So number 33, here's a decimal, 0.42. So we move the decimal 2 places to the right and attach a percentage sign, so it means 42%. Similarly, number 34, 0.087, we move the decimal 2 places to the right, it winds up here, so that'll be 87%. In number 35, at 0.365, we move the decimal place 2 places to the right, so this then is 36.5%. In number 36, we move the decimal 2 places to the right, and so it winds up between the 9 and the 2, so that'll be 79.2%. Here, again, 0.008, we move the decimal 2 places to the right, and this becomes then 0.8%. Here again, we move the decimal 2 places to the right, and this would be 0.93%. For number 46, we'll convert the percent to decimal, and remember we move the decimal 2 places to the left. So, for 41, 96%, there's no decimal, but there really is an implied decimal for whole numbers, and that's after the 6. It's an implied decimal. So we move that 2 places to the left, and it becomes 0.96. That'll be the answer for number 41. Similarly, for number 42, the decimal follows the 3 in 23. So we move it 2 places to the left, and it becomes 0.23. In this case, here there is a decimal. We move it 2 places to the left, so it becomes 0.0546. The decimal was here. We move it 2 places, so we have a placeholder 0 here. And so that would be the answer for number 43. And for number 4, it is similar. We have 2.99%. The decimal is here. We move it 2 places to the left. So this then becomes 0.0299. Again, we have a placeholder for 0 here. So that's the answer for number 44. And here, again, we have a decimal here. We move it 2 places to the left. So that becomes 0.003 for number 45. Similarly, for number 46, move the decimal 2 places to the left. That becomes 0.006. To convert 2/5 of a percent into decimal, we write 2/5 as a decimal. 2/5 is the same as 0.4%. So now we move the decimal 2 places to the left. So then the answer is 0.004. Similarly, 3.5%, 3.5 is 3.5, so 3.5%. So we move the decimal 2 places to the left, and this will be then 0.035. 8.75% would be 8.75%. Again, we move the decimal 2 places to the left, and that then is 0.0875. In the next few exercises, we are asked to convert each fraction to a percent. And again, the rule is to convert this into a decimal. And since 1/5 is 0.2, so we move the decimal 2 places to the right, so that then becomes 20%. And 2/5 in decimal form is 0.4, and you just use your calculator for computing that percentage as a decimal, and so we move the decimal 2 places to the right, and that will be then 40%. And 1/100th, well, that's 0.01, and move the decimal place to the right, and that's then 1%. And 1/50th would be equal to 0.02. Move the decimal 2 to the right, and that then becomes 2%. Again, there's probably nothing much new for you here, but at least it's a bit of a refresher. For the next few exercises, I want to give you a little shortcut. A equals B times C, meaning the number A equals B% of C. And this way you can solve for any of the numbers or percentages. So, for example, what is 26% of 480? Following the suggestion A equals B times C, where B is the percentage, then that means A equals, the percentage is 26%, and of means multiplication, 480. So then in decimal form, it is 0.26 times 480, which is 124.8. Similarly, what is 38% of 12? Again, ABC. A equals, and the percentage here, of course, is 38%. Again, of means times 12, or 0.38 times 12, and that's equal to 4.56. So A equals 10.5% of 28, or times 28. So that's 0.15 times 28. And that's equal to 2.94. And number 66, A equals, the percentage is 48.6% of, or times 19, which is 0.486 times 19, which is equal to 9.234. The next exercise is a little different, and that is what percent of 30 is 45? So now A equals B times C is a little different because we are asked what is 45, and what's 45 equals B times 30. Percent of 30 or times 30. So then we solve for B by dividing both sides by 30. So B equals 45 divided by 30, which is equal to 1.5. That's a decimal form now. So we move the decimal 2 places to the right. And that's then equal to 150%. Similarly, what percent of 48 is 20? So 20 equals B percent of or times 20. I'm sorry. 48. So then B is equal to 20 divided by 48. So it's 0.41666 or 41.6%. In number 69, we have 150 is, and now we're looking for the number. We have 25% of some number C. So to find C, we divide by 25%, or since we can write this as 150 equals 0.25 times C, dividing both sides by 0.25, then C equals 600. Similarly, number 70, 12% of what number is 3600, so we are looking for C. 3600 is equal to 12% of some number C, and since 12% is equal to 0.12, so we have 3600 equals 0.12 C, and we divide both sides by 0.12, so then C is equal to 30,000. 30,000. So dividing both sides by 0.12, we get C equals 30,000. A very common application of percentages is to find a percent increase or decrease, and a very simple way to remember is the new value minus the old value divided by the old value. And if the quotient is positive, then there's a percent increase. If the quotient is negative, then there's a percent decrease. So let's apply this to some of the exercises here. Percent increase. Here we told you ahead of time, but after 1 year on the job, Grady got a raise from $10.50 per hour to $11.34 per hour. What was the percent increase in his hourly wage? So applying the new minus old divided by old, the new amount would be $11.34. The old amount was $10.50 divided by $10.50, and that is 0.08 or 8%. That since the number is positive, it's an increase. Similarly, for the percent discount, Clayton bought a ticket to a rock concert at a discount. The regular price of the ticket was $70, but he only paid $59.50. What was the percent discount? So here the new value is $59.50. $59.50. The old price was $70, the previous price, divided by 70. And that is equal to minus 0.15 or a 15% decrease or discount. Discount implies decrease. There's a minus sign. For the next exercise, we have percent decrease between 2010 and 2018. The estimated population of Baltimore, Maryland declined from 620,961 to 601,188. What was the percent decrease to the nearest tenth? So the new number is 601,188 minus the previous number, 620,961 divided by 620,961, and this ratio is equal to minus 0.0318 to the nearest, thousands. So that would be a decrease, and so the decrease to the nearest tenth would be equal to 3.2%. We move the decimal 2 places to the right, 3.18, and we round it up to 3.2%. We want to have the nearest tenth. The minus sign indicates a decrease. In the same time period, the estimated population of Oklahoma City, Oklahoma grew from 597,999 to 653,865. What was the percent increase to the nearest tenth? So the new number is 653,865. 653,865. And the old number is, the previous number is 597,999 divided by 597,999, and that ratio is equal to 0.093234, and so in percent there would be, since it's a positive number, it's an increase, and this decimal converts to percent. We went decimal 2 places to the right. There would be 9.9 increase of 9.3%. Or here's a similar problem about profits. In 1 year, profit fell from 1.56 billion to 1.23 billion. What was the percent decrease in profit? So here the new number is 1.23 billion minus the previous amount of 1.56 divided by 1.56. And that is equal to minus 0.212, or a decrease of decrease of 21.2%. Or in this example, we have an increase. Sales rose 2.3% to 8.7 billion. What were the sales prior to this rise? In this example, we have the new value as 8.7 billion, but we don't know what the previous value was. That's what we're supposed to compute. So let's call that x divided by x. But we know that that's equal to 2.3%, or 0.023 in decimal format. So now we multiply both sides of the equation by x. So we have 8.7 minus x equals 0.023x. Now we add x to both sides. So we have 8.7 equals 1x plus 0.023x, or 8.7 equals 1.023x. We now divide both sides by 1.023, so x is equal to 8.7 divided by 1.023, and that is equal to 8.50, so it'll be 8.5 billion. It's prior to the rise. $8.5 billion. The next exercise is about blood alcohol concentration. The blood alcohol concentration, or BAC, of a person who has been drinking is given by the formula BAC equals the ounces times percent alcohol times 0.075 divided by the body weight in pounds minus the hours of drinking times 0.015. So that's the formula for the blood alcohol concentration. So suppose a policeman stops a 190-pound man who in 2 hours has ingested 4 12-ounce beers, each having 3.2% alcohol content. The formula would then read 4 times 4 ounces times the percent alcohol, 4 times 12 ounces, so that's what the amount comes from, times the blood percent alcohol, 3.2. So notice that this is 3.2%. This is not in decimal format, so it's percent alcohol, times 0.075 divided by the body weight, 190 pounds, minus 2 times hours of drinking times 0.015. So the first part is find this BAC, blood alcohol concentration. So when we evaluate this formula, this is 0.031. You just have to evaluate each fraction, or evaluate the fraction, subtract this quantity from it, and you get 0.31. Now the next exercise has to do find the BAC for a 135-pound woman who in 3 hours has drunk 3 12-ounce beers, each having 4% alcohol content. So we need to set up the formula for the BAC. So this formula would look like this: 3 times 12 ounces of beer times the alcohol content, percent alcohol, 4%, times 0.075 divided by the weight, 135 pounds, minus 3, that's because in 3 hours, times 0.015, and that's equal to 0.08. That's the quotient here, and this is minus 0.045, and that's equal to 0.035. That's the blood alcohol content. And this is the conclusion of section 6.5.